Hello. Yes, we welcome you back. The channel is PSSB, Physical Sciences Silver Bullet with me, Richard here. The question says, define each of the following and give 3 examples of each. The first one is strong acid. How do you define a strong acid? A strong acid is the one which is completely ionized in solution to give high concentration of hydronium ions. And the examples are, let us start with the 3 mineral acids, which are sulfuric acid, hydrochloric acid, and nitric acid. All these ones are strong. Then you can have hydrogen iodide or hydrogen bromide. Yeah, those are examples of strong acids. But I want the emphasis for this level to be on these 3 mineral acids. They're going to play a very important role in other chapters which are going to come. So then comes this question, says strong base. Define a strong base and give 3 examples. So how do you define a strong base? A strong base is the base which is completely dissociated. We normally use the term dissociated because most of the bases are existing in ionic form. They don't have to ionize. So because they are having ions already, what happens is just separation of those ions. That's why most of the times we use the term dissociation. But technically, there are also some bases which are not ionized already. So they undergo ionization, but most of the bases are already in ionic form. So the best term to use here is dissociation, which simply means separation. So back to the question, is the type of base which is completely dissociated in solution to form high concentration of hydroxide ions. Yeah, that is that. And examples here we have potassium hydroxide, sodium hydroxide as the best examples. Yeah, plus other group 1 hydroxide like lithium hydroxide. Yes. So I need to tell you here that whether strong or weak, the character is determined by degree of ionization. Strong acids are completely or almost completely ionized, and strong base are almost completely ionized or dissociated. So it's the degree of ionization which determines whether the acid is strong or weak. Yeah, then comes this question saying define weak acid and give 3 examples. Okay. So what is a weak acid? A weak acid is the acid which is incompletely ionized or partially ionized to give low concentration of hydronium ions in a solution. Yeah, that is that. And the examples you have are ethanoic acid, oxalic acid, carbonic acid, So these are just few of the examples of weak acids. I need to remind you that for oxalic acid, the formula is COOH bracket 2, and for carbonic acid is H2CO3. Yeah, then you come to this one, weak base. What is a weak base? A weak base is the base which is incompletely or partially dissociated or ionized to form low concentration of hydroxide ions. Yeah, so that is that. And examples, we have ammonia, it's a weak base. We have then calcium carbonate, then potassium carbonate, and others. Yeah, then comes this question. It says, compare the two acids below. So these are the acids we are having. A is hydrochloric acid and B is ethanoic acid. And the question says, write the equation of the aqueous reaction of each. Okay, we start with hydrochloric acid. So when hydrochloric acid is an aqueous solution, this is what happens. What happens to the acid? It donates a proton to the base. So what is the base? So under this circumstance, what do we have? You have water gaining a proton to become hydronium ion. And hydrochloric acid losing a proton, it becomes chloride ions. Now, there's something you need to know here, which is very important, that hydrochloric acid is a strong acid. And what do we say about strong acids? They undergo complete ionization. That means that what you have here is an arrow pointing in one direction. The acid is completely ionized. Going in one direction means that at the end of the reaction, we don't have hydrochloric acid. Okay? Then we come to ethanoic acid. What do we have? We have it written down here. Okay. In aqueous solution means it's in water and it's the acid. So what happens to the acid? It donates a proton to water. Water, on getting the proton, what do we get? We get hydronium ion. And we need to know that the hydrogen which is lost is this one. So ethanoic acid, on losing a proton, what do we remain with? Ethanoate ion. Okay, so that is what we have. You need to remember that we have an equilibrium reaction here, implying a reversible reaction, that this reaction can go forward or reverse, unlike the first one, which goes in one direction. So for this reaction, at the end of the day, we are going to have everything here present. We are having ethanoic acid present because ethanoate ion is busy reacting with hydronium ion to form it. And this one is busy reacting to form the products. So it is an equilibrium reaction. Yeah, so comes this question. It says, write an expression for the acid dissociation constant for each acid. Okay, let's start with hydrochloric acid. How do you write it? It is acid dissociation constant. So it's Ka. And the Ka is an equilibrium expression like the one we write in chemical equilibrium. It is the concentration of the products of the it is the concentration of the products over products of the reactant. So in this case, what are we having? We're having the square bracket representing the concentration. So we have hydronium ion reacting with Cl minus over HCl and water. But you have to remember something very important here. What do you have to remember? You have to remember that this reaction is completely ionized, meaning that we don't have hydrochloric acid at the end of the day. It is all converted into hydronium ion and chloride ion. That's what we mean by completely ionized. Another thing is that water technically experiences very minute change to consider it. So it's also taken out. What does that mean? It means that our Ka is going to become Ka, giving you hydronium ion into chloride ion, as simple as that. This is the acid dissociation constant of hydrochloric acid. Why? Because it is a strong acid. What do you mean by a strong acid? It is completely ionized. Then we come to the second equilibrium. It is an acid, so it's going to be Ka. And what do we have? It's going to be concentration of hydronium ion into concentration of ethanoate ion over concentration of ethanoic acid into concentration of water. But you have to remember that in this case, ethanoic acid is fine. It's weak, so it is still present at equilibrium. But we need our water, which technically remains unchanged. So what do? We leave it out. So our Ka becomes what? Becomes Ka or acid dissociation constant, giving you that into that over CH3 COOH. Yes, that is it. Yeah. Then comes this question. It says compare the acid dissociation constant of HCl to that of ethanoic acid. Write higher, lower, or the same. Explain your answer. So what are we doing here? We are comparing the dissociation constant of this to that. And what's the answer? The answer is higher. Okay. The acid dissociation constant of hydrochloric acid is higher than that of ethanoic acid. What's the reason? The reason is that hydrochloric acid is a strong acid, implying it's completely ionized, producing a high concentration of hydronium ion or high concentration of products. I'll need to remind you, let me print a picture here, that what we call Ka is concentration of product over concentration of reactants. So for HCl, which is completely ionized, what do you see? We are having higher concentration of products. So if the denominator is higher, obviously Ka is going to be higher. That is compared to our ethanoic acid. For ethanoic acid, if we look at the same, which is product over reactant, this one is partially ionized. It means that our product, which is denominator, is going to be relatively low compared to that. So back to our explanation. What's the explanation? It is higher. HCl has a higher Ka compared to ethanoic acid. Why? Because it is a strong acid which is completely ionized. So that is that. And with that, I'd like to thank you for your time. We urge you to subscribe, to comment, to like, to share. And we need also to remind you that PSSB, Physical Sciences Servability, is a science channel handling physical sciences, grade 12, 11 and 10, and natural sciences, grade 8 and 9. We advise you that when you are using the channel, don't go to video, go straight to playlist and look for the material of your level. Grade 8 and 9, just look for natural sciences grade 8 or 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. For grade 12, each chapter is presented independently. Just look for the chapter of your choice and click. There you have all the material you need. We thank you for your time. See you next time. Bye-bye.